Hello and welcome to ETAuto Virtual Summit on Advances in EV Design and Development, powered by NSYS. I'm Annie Fatima, your host for the day. Electric vehicle market is poised for stronger growth. It is likely to be around rupees 50,000 crores by 2025, with two-wheelers and three-wheelers to lead adoption in medium term. The charging infrastructure market is also expected to grow by 40% in the same period. The battery cost is also expected to hit $100 per kilowatt hour in the next 5 years, marking EVs economically competitive. There are, however, several challenges that need to be addressed from a technology point of view. The range anxiety and charging time are still considered as a hurdle in adoption. Battery reliability and life are still the factors that worry the OEMs. For India, success of EVs will be largely determined by ability to localize the design and production of EV powertrain. This virtual summit will try to uncover some of the advances in electric vehicle design and development using simulation solutions. Industry leaders and technology enablers will try to bring out various challenges in self-reliance for Indian electric vehicle development and how simulation-driven design and development helps to counter them. This virtual summit is a collaborative effort supported by an ecosystem of partners, and I would like to take a moment to thank our powered by partner, NSYS. Now, without much ado, I would like to invite Chetan Mani, co-founder and vice chairman, Sun Mobility Private Limited, for a keynote talk on the topic Advances in EV Design and Development. Over to you, Mr. Mani.
Good morning, everyone. Pleasure to be here today. Let me just try and share my screen here so we can start off. Hi, good afternoon, good morning, everyone. Pleasure to be here today on this area. As we know, the future mobility is going to be driven by 5 key areas: electric, connected, shared, autonomous, and powered by renewable energy. And I think the new businesses and technologies are not just going to be at each of these points, but also the intersections. So as we think of electric, connected, and renewable energy, for example, we're going to be looking at not just the mobility space, but how also energy integrates with mobility. And these are going to give us new engineering opportunities and, of course, business opportunities as we look at it. Now, as we think of India, right, we've except for the COVID part right now, we're around 23 to 25 million vehicles a year. And a large portion of our vehicles are in the 2- and 3-wheeler space on this front, right? In fact, 85% of mobility in India is on 2- and 3-wheelers and buses, right? And surprisingly, we have high penetration in certain areas, right? We have e-rickshaws that are around 350,000 sold every year, 100% electric. By 2030, we expect that probably 60 to 75% of 3-wheelers will go electric, right? Goods carrier would probably be between around 30% by 2030, and 2- and 3-wheelers will be between 45 to 20 to 45%, 40% by 2030. So if you look at this sector of just the 2-wheelers, 3-wheelers, and buses, right? By 2030, around 47 million vehicles of EVs in this form factors would be in India. And so that's a big transformation in terms of how we would think of what we're looking at electric mobility on this front here. If I were to look at from a consumer point of view, what does this mean? Well, there's going to be one area on shared mobility, that high orientation on that, which means new form factors, specialized vehicles that are more for fleets and shared mobility for delivery, and combination of personal shared mobility will start to be on the rise over the next 5 to 10 years on this area, right? I think people are also really concerned about the costs, and so the challenges are going to be around how we're able to reduce the costs, upfront costs, to make them similar to IC engine vehicles and operating costs. And in smaller form factors, this is going to be more challenging for us to do on this area because the battery costs still contribute a large portion of it, right? The third area is going to be around the range flexibility, to what was alluded also right in the beginning here, right? The ability of vehicles to operate without the range limitations are going to be very critical, right? The fourth customer demand is going to be around quick refueling, right? Minimum downtime. People are used to 5 minutes of refueling. Anything beyond that seems like eternity. And how do you create models and technologies that enable quick refueling, right? And the last part is around this hassle-free experience, right? Batteries are a new aspect to it. Maintenance and cost associated with it is something that people are not very comfortable with. So you're going to have a set of new business models, technology, and appropriate EV infrastructure that can help meet these consumer demands, which are really going to accelerate the adoption of electric vehicles. And just to take a second to discuss on, the infrastructure side, and then we'll get to the other parts on this front, right? I think there's going to be a combination of infrastructures that are being used. So let's take two form factors of transportation: small vehicles and very large vehicles. In the case of 2 and 3 wheelers, if they're for smaller distances, great AC home charging works really well. And as you look at larger distances, that you look for shared mobility on this front or for commercial delivery, you're going to see battery swapping playing a very large role on this area. That really addresses the range anxiety, the long refueling time, as well as the upfront cost. If you look at from a bus point of view on this front, for smaller buses, they go and sit there in a school bus, for example, for 8 hours. Low distances, AC charging, regular charging would be great. As you start to get mid distances, you're going to have probably areas where DC fast charging plays a large role in employee commuting and certain applications like this. And then as you think of larger ranges where you want and high utilization on this area, your battery swapping and ultra fast charging will start to play a large role. So what we're going to see is a combination of infrastructure solutions for different segments of the market. There's not going to be one size that fits all, and they're going to coexist in this period of time. And so technology development has to happen parallelly, depending on the market segments and areas that we look at. And so as you look at what this means for the opportunities, ahead of us, right? So the auto industry, as you're aware, is close to 7% of our GDP. So by 2030, this is going to be $350 billion, right? And of course, this means the newer products that we talked about, India centricity is going to be an important part, right? The second thing is that 50% of the bill of material of electric vehicle is different, which means there'll be a new supply chain of over $75 billion related to powertrains, motors, controllers, transmission, chargers, batteries, BMSs, air conditioning, autonomous technologies, all are going to play a very large role in this new supply chain that didn't exist. And here is probably where the engineering and the capability we're going to need to create is very different than what has existed in the past on this area. The third area is the world's going to move to more solution-based areas, right? So shared mobility solutions, charging infrastructure solutions, energy integration, software technologies. There's going to be a large percentage of added value businesses that didn't exist in the past, or some of them did, but they're going to completely transform themselves as they go forward, right? And then energy business also will change, right? Because you're going to have batteries, renewable energy, swapping stations. By 2030, this is over a $20 billion market on this area, right? And the entire ecosystem technologies related to charging, battery swapping, vehicle to grid, connected car, big data are all going to play large opportunities. So we're in a fabulous space of transformation today as we stand in terms of what we're going to see happen in this industry as we take this forward, right? So this being more of an engineering focused area on this front, right? How do I see the focus, what engineering needs to be doing in related to what we see the opportunities are, the challenges are, and how we could address them. So I think the first is there's going to be a lot of work on purpose-built EVs. And you've seen recently a new level of collaboration of ecosystem partners and OEMs, which haven't happened in the past as much. So, where Amazon and Rivian is working to create, delivery vehicles at scale on this area, or how Uber and Lyft are working with autonomous taxis, or Bounce is working on private OEMs to see how they can provide solutions, is going to be an area of a lot of purpose-built vehicles that would come at reasonable scale and optimization, right? I think with the new policy, import challenges in supply chain may offer huge opportunities for us to start going to India to develop in India quicker than waiting for 3 to 5 years. And so we shouldn't miss the boat like we did in the case of solar cells, but we can have an opportunity here to have core technologies upfront in India, especially the market being large here, right? It's also going to be important for us to develop cost-effective solutions that leverage open architecture approaches to reduce time and cost on this area. And this needs to be a philosophy right through in a way where open architectures can actually be beneficial without creating a limitation. And I'll spend a little bit more time on this point because I think it's a very valuable point as we look at this going forward, right? There's going to be a need to standardize components and architectures, but still keep flexibility. So if, for example, I'm just giving you some examples, all small form factor vehicles were around a 48-volt architecture, that would create a huge amount of standardization. And today a 48-volt system can go everywhere from 250 watts to 20 kilowatts, which means that composes of 23 million vehicles produced in the country today. You could have one architecture without compromising performance on this front, right? Standardized hardware related to BMS motors and controllers, but flexible software will help us enable to have very optimal supply chains on this area, lower our costs significantly, but still keep flexibility on this area. Now, if you take the components being this way, you could take another approach on platforms, right? Where the platforms also could be modular on this area, and then these use standardized components on this front, but still create product differentiation. So we have to rethink a little bit our approach on platform and components if you want to kind of get the level of scale, but you also want to keep the personalization that OEMs would like to do. And this requires a very different approach, but it has a huge impact on how we can think about it. It also means that all of these technologies need to be on a platform that can be easily leveraged on this area, right? If I take this further, the next step for I start looking is how do we optimize our resources on this area, right? And utilization of local make materials. So an example would be using motors with low usage of magnets or no magnets, right? We need to think about this at scale because today in India, we don't have some of these resources, right? We also need to be thinking of how do we reduce imports and innovative models. So let me give you one example, right? If you today batteries last you around 1,000 cycles typically, right? But if you could use higher life cycle batteries with swapping on this area because you can cool them offline, you could get a 4,000 cycle battery. And because you're swapping, you use half the amount of battery size, which means you could get an 8x utilization of assets or 1/8 the amount of lithium for the same vehicle over its life cycle. These are the things that are going to tremendously impact how we think about natural resources and on this area, because initially it's fine, yeah, you get the first few thousand or million out there, but when you want to get 50 million out there by the end of by 2030, we have to really think about these in a very different way, right? We also need to look at that the world is actually flat and we have to think global. The powertrains that you would use in a scooter in India would be similar to what you do in Vietnam or Africa or even Europe, which means that the technology is getting democratized and what you need to be thinking is global on anything you're looking at, but of course tweaking that for a local market. But it is very, the technology here is very similar today. When people think of an Android phone or an Apple phone or anything, it's not different when it's sold in different markets. And you have to be thinking, where do we thinking from that perspective, especially on technology on this area, right? Advancements in hardware and software are going to be critical for us to develop software systems that are optimal for Indian use and leverage our talent here, right? Software can play a very large role in optimization. We could improve efficiencies by 10-15%, which means cost of energy could come down tremendously on this area here, right? And I think we should also look at solving certain universal problems on this area. I'm just giving an example. What happens for batteries after 5 years? How do we calculate the residual value of it? How do we reuse them in the field so that they can be recycled, right? How do you start to create generic apps around EV interface and stuff? So there are going to be a lot of challenges that are very universal, and this is going to help the entire industry. So how do we as an industry come together to solve some of the larger problems which could help everyone and not just one company on this area, right? So what does it mean for us? Well, as engineers, I believe that you need to think across electrical, mechanical, electronic streams for mobility. It's not about you're an electrical engineer, mechanical engineer, right? There needs to be strong systems knowledge to solve problems on this area. We need to integrate advanced software technologies. Almost software needs to be part of another language that you know, right? And I believe in this area of what we're trying to do, virtual engineering and simulation is going to be a tremendous work to help accelerate on this area. We talked about standard motors, standard controllers. Imagine not only did you have physical models, but virtual models of each aspect of the new battery, of the motor, of a controller, of a certain tire of area. How quick you could simulate and create new product. If someone developed a new technology and with that gave you a virtual model, imagine how fast you could do things on this area. So how do you start to democratize virtual engineering and simulation along with components? How do you start to think of the world in the future as being flat and open architecture as you start to solve these problems? Which means collaboration is going to be very critical as we think of reducing our time to market on products, right? Across OEMs, across energy providers, across partners on the ecosystems, right? Optimizing our products and technologies through these partnerships, creating modular solutions, and really looking at new business models. So it's really time for us to rethink technology development business model. But it's a fabulous perspective. I mean, you're in an industry that's probably going to grow 50 to 80% year on year, which means this is the most exciting place to be in. It's going to be highly transformational. And you're looking at innovation in multiple axes. Typically, innovation happens in single axis. But on one side, you're seeing technology that's changing at a battery level, at motor level, at controller level, at vehicle level. You're looking at energy being changed, the way you think of distributed energy. You're looking at infrastructure being transformed on this area. You're looking at user ownership changing to usership. So you're seeing the variance coming in multiple axes. And this means that this future is really exciting. And it's a great start to what you're going to have today around the simulation and virtual engineering, because I think it's going to play a very important part in helping India achieve its goals of trying to get at least to 30% electrification by 2030. Thank you so much.
Thank you, Mr. Mani, for an engaging session. Now we'll move on to the next session. It's a presentation by Dr. Preet Banerjee, CTO NSYS, on the topic Accelerating into a New Era of Transportation and Mobility, an Electrification Revolution Powered by Simulation. Over to you, Dr. Banerjee.
Thank you very much, Heini. I wanted to acknowledge my co-presenter, Tarun Tejpal, Global Director of Transportation and Mobility, who assisted me in putting together these presentations. So I'm going to talk about accelerating the new era of transportation. And just to set the stage, I wanted to kind of share some statistics of the market for EV. By 2025, EV sales will hit about 28%, and by 2040 it will be 58%. So the global market is huge, and in China the amount of electric vehicles will go to about 70% by the year 2040, and even in India, if you can look at the chart, it's going to expected to go to about 30%. So huge growth in EV, as was mentioned by the previous speaker, Chetan. Within the electric EV area, there is sort of different vehicles, but if you look at it, buses, these sort of community buses are supposed to grow at the fastest rate. The next is two-wheelers, and then you have passenger cars. The heavy commercials will grow the slowest in terms of EV adoption, but there's tremendous growth by segment, right, in the EV area. So now you kind of look at, in India, what is driving EV, electric vehicles, right? First is the government incentives, right, where up to the income tax rebates are providing growth for that. That's the goal, 30% EV by 2030 by the government rebates. Second is climate change, because India joined the Paris Agreement, you have to cut the emissions, and that is clearly a factor. Third thing is energy security, right? The dependence on oil. You want to be independent of the dependence on oil. And the fourth one is rapid urbanization, right? So as people are going towards more and more urbanizations, so basically to take care of this this market, this rapid growth and all these challenges, right? So the auto industry must innovate, and essentially what we are saying is that the auto industry has to innovate in an exponential manner, really, really fast, to take care of these transformations. So, and we believe that this exponential innovation will be provided by simulation. And if you look at when you introduce a new car, right, all the automotive OEMs, they have to do lots and lots of road testing, right? The CEO of Toyota said that for autonomous vehicle to be safe for car driving, you need to drive 9 billion miles, right? So it'll take a long time for these OEMs to drive those cars on the road with actual road testing. And this can be accelerated by a factor of 1,000 by doing faster testing and safety engineering through simulation. So that is essentially the statement that I'm making here. So what we did was we partnered with Volkswagen and we helped them win the Pikes Peak race uh, using simulation alone. And the way we did that was to work with them on the size of the motor, the size of the battery, the weight of the battery, and essentially they could not do any road testing. The first time this car ran was on Pikes Peak, and to see that this is what happened, and they were able to beat the world record in about less than 9 minutes. So this is the type of simulation-based product innovation that can be done through simulation. So a quick look at ANSYS. ANSYS is focused on digitalization, on 5G, autonomy, electrification, additive solutions, and so on. And we have more than 45,000 customers across different verticals, and automotive is an extremely important vertical for us. And we have 4,500 employees and a very significant presence in India. So now let me talk about the EV challenges. I think some of the challenges were mentioned by the previous speaker. You have to simultaneously take care of performance where the range of the car has to be at least 500, 400 miles. You take care of the different standards that exist, right? The ISO 262, 262, and the cost, right? The cost has to go significantly below sort of $100 per hour and so on. So, and simulation can enable all three of these challenges. So so basically what ANSYS has done is to provide capabilities in terms of four pillars. When you look at electric car compared to an internal combustion engine, right? Instead of the engine, you have electric motor. So you have to have a lot of sort of research going on in how you build electric machines. And that's enabled by our Maxwell tool and is a set of tools that go around it. Then to drive the electric motor, you need power electronics, you need inverters and so on. You have to simulate those power electronics. So that's the second part. Third part is the battery that will allow you to go more than 400 miles, right? And essentially you have to model the battery cells, the packs, the entire frames and so on. And the last thing is the entire powertrain integration. So essentially by innovating around these four pillars, you can advance EV design. So I'm going to take each of these areas and talk about the challenges and some of the results, right? So essentially the challenges of building electric machines, whether it's permanent magnet electric motors or AC induction motors, basically the challenges are how do you have increased power density, increased efficiency, and so on. And essentially what we are trying to do is how can you design a electric motor which is 12% more improved in terms of power density and the cycle time reduction. Essentially the design, it can, if you want to go after this kind of power density, the times required are like thousands of hours, and through simulation you want to reduce it by a factor of 16. And also you have to reduce costs, right, in terms of all the different materials that are used. And through our Granta materials information platform, we can provide those solutions. So essentially this is how we partner with our customers, right, in terms of providing multidisciplinary optimization with our OptiSlang tool, and essentially taking different tools out there from Maxwell to OptiSlang and so on, and Twin Builder, building reduced order models, and then essentially uh, measuring the noise vibration through our ANSYS mechanical. So a set of tools to design the electric motor and to reduce the noise and do it in a multidisciplinary optimization approach. So essentially what we have to do in terms of simulation capability is how do you do the design and specification, how do you do advanced magnetic analysis, how do you do torque analysis, et cetera, et cetera. And so we have essentially worked on these solutions to help our customers in the electric motor design area. The second area is that of power electronics. Again, I'm mentioning some of the challenges here, the challenges of high switching frequencies, the challenges of over voltages, thermal reliability, and so on. And again, in terms of the challenges that can be solved through simulation, it is how do you do improve performance, right? So typically, if you do the solution of these things with at the 3D simulation level, it takes forever to do the simulation. So using reduced order models, you can speed up the simulation by a factor of 2000, right? That's the capability that we can do. Again, reducing design cycle time, extremely important. We have been able to show cycle time reductions in power electronics by about 75%, and cost reduction in terms of productivity gains. Again, significant advantages. So we have, for example, worked with Ford Motor Company in terms of their traction inverter design, right? Again, using our simpler tool for power electronics and combining that with motor designs, motor CAD, and so on, we are able to do the power electronics design and essentially combining our twin builder solution, our Maxwell solution, Q3D solution, iSpec for the electronics and the electrothermal. So putting out all of this together, you can actually, the customer can do these entire, again, design space optimizations using OptiSlang to drive for the best inverter design. And essentially that allows our customers to do this multi-level modeling using ROMs, solving for EMI, EMC for power electronics and the PCB reliability. Third pillar is that of battery and battery management systems, right? In electric car, instead of an internal combustion engine, you have electric car powered by battery, and we have models of the batteries at the cell level, at the system level, and so on, using our Fluent software. So essentially the challenges that we can solve in our battery management systems are improved performance. Again, the same thing, right? If you want to simulate these using full fluid 3D simulation, it takes forever. Using reduced order models, you can run them 1,000 times faster. You can do design cycle time reduction by a factor of 50%, and again, cost reduction by 30%. So in the battery management area, we have actually worked with Volkswagen Motorsport. This is the example, the video that I showed you, right? Essentially, the main challenge in that electric car design was the design of the battery, because when you have to go win a Pikes Peak race, right, you can increase the speed of the car by having a larger and larger size motor. But to drive the larger size motor, you need a larger battery. And so, but if you increase the larger battery, the weight of the system goes up. So essentially, we partnered with Volkswagen on doing this system level modeling, right, of what is the right size battery to drive the right size motor for winning the Pikes Peak race, right? So this is an example of how we combined our reduced order models from Fluent, combining it with a twin builder for these ROMs and the real-time models and so on, allowing our customer to do the system simulation. So that's an example of the battery model. The last one, and essentially through that, what you can solve is the cell and electrode thermal problems and EMI, EMC, battery management, and so on. The last pillar is that of power integration, right? In the powertrain, you have the electric motor, you have the power electronics, you have the batteries. How do you pull it all together? And now you have to solve problems of increased switching frequencies, over voltages, thermal reliability, EMI, EMC. So the challenges that you can solve through simulation is, again, speed up the simulation of the entire powertrain by a factor of 2000 times. Again, that is enabled through our reduced order models. Design cycle time reduction by about 75%, by essentially doing a compressed PCB development time, and cost reduction. So now you have to take a look at all these things, right? And we have worked with a customer. This is a particular customer, the electrified propulsion system integration, taking our ANSYS 3D solvers, the high fidelity solutions, our real-time models, and the twin builder, and looking at SCADE Medini to do the functional safety. The safety is a very, very important role to solve, and essentially maintaining our ISO 26262 protocols and so on. So taking a look at this, right, essentially this allows our customers to do architecture simulation through our SCADE Medini tools, high fidelity models, systems integration, and embedded software design. Now you take all these four pillars, the electric machines, where you have to do 12% performance improvement, 16 times design cycle time reduction, cost reductions, and so on. Power electronics, 2000 times performance. Battery management, 1000 times performance. Power train, 2000 times. So you add it all together. This is how you are getting the exponential gains, allowing OEMs to drive towards more electrification solutions. That is essentially the share that I wanted to share on the simulating the future of mobility. What ANSYS is doing is partnering with customers such as Volkswagen, such as Ford, such as and other companies to help them drive towards the future of mobility. Thank you very much.
Thank you, Dr. Banerjee, for showcasing the importance of simulation to accelerate EV design and development. Simulation would be a key enabler to deliver on the product promise. For electric vehicle and few of the examples you showed highlight the importance of simulation for EV development. It was a pleasure listening to your session. To discuss on what it takes to design and development of world-class electric vehicle, we have a panel discussion comprising of industry leaders who bring significant experience of working on EV technology. Let's move on to the discussion on realizing self-reliant India for EV, R&D challenges for design and development of EV components. I would like to invite Nabil Khan, editor ETAuto, to moderate this discussion. Over to you, Nabil.
Thank you, Annie. Thank you so much. I must say, this morning we had a fabulous start with a lot of insight coming out from Chetan Mani. Chetan Mani is probably one of the few technocrats who has started the electric drive in India, or the person who seeded the idea of electric vehicles in India. Then we had this exciting technology session by Mr. Banerjee. I see a very exciting day ahead with the fabulous speakers, and I just want to tell the viewers today of ETAuto that this panel discussion is not going to be just superfluous, but it is going to take deep dive understanding how the electric landscape is shaping in India and how is it going to be like. So that's why we have in this panel the people who are really driving the change when it comes to electrification, those who are actually acting on the subject, those who are really creating the ecosystem for EV. They are the people present in this panel discussion. This panel discussion is deemed to be very interactive and engaging. I would request the audience to feel free, pose your questions. We'll try to take as many questions as possible in the last segment of this session, and also we'll try to get them answered even after this session if time doesn't permit. So let me introduce to you today's subject matter experts and people who are driving really the change when it comes to Indian automobile industry in terms of electric vehicle. The topic for this session is very relevant: realizing self-reliant India for electric vehicle. R&D challenges for design and development of EV components. So we are going to talk about components. We are going to talk about entire vehicle, how it can be localized, how can India become Atmanirbhar in this new age mobility, which is electric vehicle. So without much ado, let me introduce to you Mr. Tapan Sahu, Executive Vice President, Engineering, Maruti Suzuki India Limited. We also have Mr. Anand Bhagankar, Executive Vice President, Head of R&D, Platforms and SQE, Piaggio Vehicles. We also have Mr. Girish N. Ramaswamy, Head of Engineering, Engine and Drivetrain System with Desco Technology. We are also happy to welcome Mr. Sheetal Joshi, Head Electronics and Electrification at ANSYS, India and ASEAN region. Thank you so much, gentlemen, for taking out time and joining in today. So we are talking about Atmanirbhar Bharat. Our Prime Minister has given a huge call, and every company, corporates, and manufacturer are trying to center their focus on this subject. So my first question would be to Maruti Suzuki, because Maruti Suzuki is one of the company that has adopted highest level of localization when it comes to the traditional vehicle. Now, as we move to electrification, Mr. Sahu, what are the key broad level of engineering R&D drivers for accelerating EV adoption? Do you think localization will play an important role in this?
Yeah, Nabil, thank you very much for inviting me to this panel. I think it's a very good question that you have posed. What are the key R&D drivers for larger adoption of electric vehicles? So let me put this in context. I think first of all, when we are talking of adoption of a new technology like electric vehicles, we have to look at where it is coming from. So we need to understand before we get into the R&D of the vehicles. I think we need to understand first what is the country objective, and then from the country objective, what is that the customers are looking at, and therefore what should be the R&D drivers or the R&D challenges. So if you look at country objective and from India's perspective, our key challenges today are the energy security. That's the first and fundamental challenge which as a country we are facing. And second, we also have our COP21 commitments in terms of carbon emission. Both these relate to the same thing, that how do we save fuel, how do we save energy, how do we enhance or widen our energy mix in the country, so that not only from vehicle perspective but also from other energy users, we are able to take care of the country's requirements in future. And therefore multiple activities are going on in from the government side in terms of balancing the energy mix. Now coming to the carbon emission, also COP21 government has given certain commitments, and auto industry is also working in that direction in terms of reducing the fuel consumption, or the CAFE norms are going to come in. So these are the two country level drivers which are there. Now when we translate that into electric vehicles or electrification or electric vehicles as a basket, which means that okay, we have strong hybrid vehicles, we have plug-in hybrid vehicles, we have electric vehicles. How do we look at that as a basket, and how do we look at it from a customer perspective? From a customer perspective, today, if we look at electric vehicles, there are three challenges that are there. The first and foremost fundamental challenge is that there is a challenge of cost. Today, these vehicles are extremely expensive. Typically, we compare with EV proliferation in other developed countries like Norway or Netherlands or other countries, and we say that okay, EV proliferation is going on at such a fast pace. However, if you compare the income levels of the consumers there or vis-a-vis the product price availability there, they are vastly different. Therefore, we need to put that into the customer context also. So cost is the first challenge that we have for a EV. 2.5 times, 3 times is the current cost compared to conventional vehicles. The second is the challenge of charging infrastructure. Okay, that okay, if we don't have charging infrastructure, how do we do it? And therefore, the third factor which comes to consumers from consumer perspective is the convenience. Is it as convenient as I am using a conventional vehicle? Will I get stuck somewhere? Will it not give me any problem on the road? Will I be able to charge my vehicle? So these are some of the concerns that consumers are having today, and therefore, if you take these 3 points, the cost, convenience, and the charging infrastructure as three challenges, then that will translate into the challenges for the R&D engineers. So looking at it from cost point of view, I think the point that you made about localization, I think definitely localization is a must if we want to get in the direction of Atmanirbhar Bharat, because we don't want to get into EV and say that okay, our imports have gone up. Definitely nobody would want that. No industry would want that. No company would want that. And we must ensure that when we are looking at electric vehicles, hybrid vehicles, strong hybrid vehicles, plug-in hybrid vehicles together, we are not going to increase our own imports. We should be able to localize. Now, what is the way to localize? There we have a challenge today in terms of having a chicken and egg story, that okay, we don't have demand, therefore we are not able to get the scale from a component maker perspective, therefore we are not able to localize, therefore the cost is not coming down, and therefore again it is spiraling back because cost is high, the sales are low. So we have to break this vicious cycle. And how do we do that? We can do that if we look at from two or three perspectives. One, from a component perspective, we should look at from R&D perspective that okay, how do I make my components similar or same, and how can I aggregate these components across technology, across the kind of XEVs or electric hybrid vehicles. If I just give you example of passenger vehicles, I think a strong hybrid vehicle or a PHEV or a EV would have a similar range of motor because they drive the vehicle on their own. the vehicle can run. So 50 kilowatt motor or something like that. So 50 kilowatt, 70 kilowatt, 90 kilowatt. You can have range of motors from R&D perspective, and then aggregate the demand across different range of these type of vehicles, and therefore you'll be able to get the scale. Number two, modularization. The second part is that, okay, we have components which are like power control units which are used in electric hybrid vehicles, the batteries. So second R&D challenge will be that how do we modularize and use a set of components. We have a range of vehicles today in India, and therefore if the range is there, if the range of vehicles are there, then uh, from a smaller vehicle or a hatch to a sedan to a SUV, how do I make a different modules of battery packs to be used in the vehicles, and therefore make my design simpler and make my system architecture modular, and also then aggregate the demand for localization. So I think that's my view, that if we want a really large level of EV proliferation, we have to look at this basket of electric and hybrid vehicles together, which will be able to help demand aggregation. We need to look at modularization and localization as a must for overcoming the cost challenge. Coming to the
Thank you.
convenience part of it, yeah. Coming to the
Yeah,
convenience
please.
part of it, I think if we talk about convenience of customers, so we have to look at in addition to the slow charge vehicles which are available today or some of the fast charging vehicles, we need to also look at fast charging. So which should not take much time for the consumer to charge. So today the consumer gets his petrol filled in 5 minutes, let's say. We may not be able to go to 5 minutes, but at least in 10, 15, 20 minutes, half an hour, 1 hour maximum, can he get a full charge? In half an hour or 20 minutes when he's having a coffee break, can he get a charge which is sufficient to take him to from point A to point B? I think these are the kind of R&D challenges that we need to look at and uh, overcome them as far as EV proliferation is concerned.
Thank you, Tapan, for pointing the exact the barrier of cost convenience. I'll come to you, Anand, and understand your thoughts on when we talk about localization. The biggest role here is the cost of cell. We do not have cell manufacturing. Even if we start, we do not have the key minerals or the chemistry available in India. We do not have cobalt. We do not have lithium ion or these kind of products available in India. Then how do you think that the core cost competencies can develop in India, which has been forte when it comes to traditional vehicle? We are the already one of the smallest biggest market for small car manufacturing. Do you think India can fit itself on the global pedestal when it comes to cost competitiveness in electric vehicle, and what are the ways that we can achieve that?
Okay, good morning. Thanks for having me on this panel. Well, let me extend my comments and take certain clues from what Tapan just mentioned, right? In that, it was always for us also, we at Piaggio, we are in the last mile connectivity business, and where the cost is equally important part when we are looking at these products. Having said that, localization is important, as he mentioned, chicken and egg story there, right? Not necessarily all the localization will be beneficial to address this overall vehicle acquisition cost issue. Having said that, what are those components that we can definitely localize on a priority in India? We should identify those, and those can be, as Chetan also extended, how far we can commonize those not only within the same product portfolio what one OEM have, but across the industry also, so that the overall localization will bring the cost down. That is point one. Point two is, yes, as you correctly said, there are certain resources, natural resources, where we are completely dependent on the other world partners, and which should not be the again case. Okay, instead of petroleum product, now we are going to import the minerals to make these battery cells and whatnot, and then overall our bill goes up of import. But having said that, there should be a good balancing act that we all as an industry and have to really take those appropriate steps and find our individual partners within India and global partners also. Having said that, when the cost of acquisition, I'll come back to our overall thought process also. Yes, if we would like to have the early adapters in EV, primarily as all along in all forums it has been discussed that two-wheel, three-wheel, these would be a primary drivers for adapters, then fast cars would be there, right? So two-wheel and three-wheels, that's where we were elaborating that which kind of solution, because there are various range of solutions that we have available globally as well as we have developed within India also. How can we adapt it so that we can address multiple, all of these aspects, cost of acquisition, operating cost, then range anxiety, convenience also, and that's where we as a company, we have gone ahead with the swapping technology as the first one in India within the organized sector, wherein the cost of acquisition is almost at par with our any IC engine product, as well as the operating cost is anywhere between CNG and LPG, right? In that range, we have taken the cost of operation also in the equation. The other element is the anxiety part of it, and within how many minutes that I can recharge and refuel my vehicle also. So that is also at par with all the solutions or the energy solutions that we have, be it CNG, diesel or petrol. Within a couple of minutes we can swap and then we can go ahead. So this was one of the solutions that we have developed, but nevertheless, as India is a diverse country, if, then the requirements within the all part of India would be different. So certain part of country would be looking for a fixed battery solution. Certain would be adopting metros or suburb urban areas. The swappable can be a viable solution. This is where that overall while we were thinking on these localization content, then overall product portfolio perspective and modularity perspective, these all thought processes we have really nailed it properly, and this is where one after the other launches are coming into picture from our organization. The sustainability, it is only okay OEM, then we have to really look at from the end to end, from our supplier to OEM to our dealer partner networks also, right? If we have only one or two products just for the sake of it, their overall dealer viability becomes a big question mark. And this is where, as you correctly said, we are looking at product portfolio wherein the modularity can be applied, and then we have a multiple product range which can have a sustainability for the our dealerships also.
Thank you so much. In the interest of time, I would request all the speakers to be a bit precise and pointed. Thank you so much, Mr. Vagankar, for this lovely answer. I see that the cost hurdle is going to be overcome sooner than we expect, because the projections say that the battery cost is going to come down to 7,500 per kWh. Equally, the key components like AC/DC converters, cables, and all these cost is going to come down by 20 to 25% in next 2-3 years. That's the estimation. So I think the competitiveness of electric vehicle is already inching almost closer to the conventional vehicles. I'll come to you, Ashish, and understand if we go specific to critical EV components like battery, motor, power supply system, what is driving design localization needs, and what are engineering design challenges that we see? Can we take specific examples of components, Ashish?
Yeah. Good morning, everyone.
Now, morning, Ashish. Nabil san, if I can just interrupt for a minute. I need to log off actually. So if you have any questions, so thank
Yeah.
you very much. But could you permit me?
Yeah, sure. I expect you to join back if you're done with your emergency thing. Okay.
Good morning, everyone. Thanks a lot for inviting me on this panel. So coming to the question, it's a very critical and important question as far as India's EV development is concerned in days to come. What is driving factor behind the localization? I would say, government policies play a very important role there. And we see, and we all must acknowledge today the efforts that India has taken towards this, the Indian government has taken towards this. We see the FAME subsidies that come has acted as a double, edged sword today. On one hand, it is trying to propel the high volume demands within the country. That's what our elite members also talked about, just before me. And on the other hand, the eligibility criteria for availing such a subsidy point out towards more and more make in India localized components for EVs. Uh, this has propelled a huge demand, and all OEMs and component manufacturers providers are going aggressively now towards EVs. If we see, I mean, localization has been a challenge for EVs in India. If you see, the most of developments have happened in the in last one decade, and that to the second half of the decade itself. But it's good to see that a lot of aggressive technologies, adoption of technologies to produce new technologies. All those things have happened fairly. Coming specific to two-wheeler electric vehicles, where ether energy plays very important and pivotal role in India today. Yes, if I take example of the core components like let's say battery or motor, then yeah, there are a lot of design challenges which go around it. One thing is, yeah, it's not that batteries were not there, it's not that motors were not there, but it's the form factor, how we can bring them and fit it into our vehicle, right? Within a very limited space. On the top of that, there are Indian users condition, Indian climatic conditions, which are harsher than how it is in any other country, where EV is already ramping up a lot. So these are some other technical challenges, engineering challenges, which come onto top, of what already exists behind the technology as adopted in other countries. If I talk about motor, let's say motor in itself is a multidisciplinary, skill sets are required there, and that's why investing efforts, time, developing your skill sets to understand these technologies better, so that these things can be adopted in electric vehicles is very important. We have thermals requirements, we have motor controller which comes, and system level understanding, fine tuning of algorithms, so that we can harness the best out of the motors. These stuffs are requirements. Then we have thermal requirements for the motors. For Indian condition, again, as I said, it is very drastic. So these are very core challenges which are very specific to EVs, especially to two-wheeler, which I just talked about.
Thank you, Ashish. Of course, India is a country which varied temperature, varied geography. So we have some region where you have very hot weather, somewhere you go down, it's very cold. So to managing that, it's a completely different task compared to other market. I understand that. I'll come to you, Sheetal, and understand from you, from engineering design point of view, how can Indian industry develop these components at lower cost, yet having world-class safety, reliability, and performance? How do you see the technology going to help the Indian manufacturer be Atmanirbhar and produce low-cost component for electric vehicles, which are yet world-class in terms of quality? Sheetal, we can't hear you.
Yes. Sorry about that. Thanks, Nabil, and hi to all fellow panelists. Yeah, this is a very nice question, Nabil, and I'll start with what Chetan had said earlier, that for developing a local technology platforms plus having the Atmanirbhar kind of realization, we will have to go for virtualization is going to be the key. And in virtualization, there is something called short term and long term. In a short term, virtualization is not a new phenomenon. Okay, that existed for quite some time, and kind of the domain like model-based engineering or kind of simulations and CAD and all, it's already there. But the testing and validation is the area which would kind of see the biggest gain by bringing the virtualization, by bringing more virtualization. Okay, so that's in a short term. And specifically, just to elaborate a little bit more on that, in testing and validation, we do have kind of hardware in loop, software in loop, component level, which are before prototype, and there are test tricks, component test tricks, and all after prototype. There are always differences between these two. There are always corner cases comes up and kind of when you do the final testing. So why is the gap? Okay, and this gap is because there is a change in the fidelity of model that we used in the virtual testing beforehand. So what industry is going forward, and I think in India also it's quite relevant, is to use high fidelity simulations, which Ashish mentioned, for multi-physics and all, for the virtualization at the early stage. And technology is available right now. I think that was kind of difficult for IC, but I think for EV, it's very much possible. And then that would avoid surprises at a later stage. That would avoid kind of corner cases, and that would give much more confidence to our OEMs when they go for a final testing. And second, in long term, I would say creating a modular solutions to create a interoperable virtual models and for the component and systems that can be used across the organizations or the kind of supply chains. Strong system knowledge is critical. There cannot be silos between kind of design, testing, validation, or mechanical, electrical software. Software itself is a key role. It's playing much important role for even increasing efficiency by 15 to 20%, as again one of the speakers said earlier. And then finally, creating a model-based system engineering environment along with a digital framework that allow interoperability, creating and exploiting multi-hierarchical models, multi-physics models, and kind of multidisciplinary mechanical, electrical software and controls all together. So these are the kind of digital transformation I see in a short term as well as medium term that would help propel the innovation as well as help towards the Atmanirbhar campaign that we are into right now.
Thank you, Shital. I'll come to you, Girish. How important is optimizing EV powertrain as a system as against optimizing at component levels? Both software and hardware component, do you think the trend such as model-based system engineering help in better optimizing design for EV?
Yeah, thanks, Nadeem, Nabil, part of this panel. Yeah, definitely. I see model-based development is not new. It was in place for a very long time, and we cannot imagine our development, especially on the component side, even on the system side. When you talk, without model-based development, the time to market we cannot, achieve. So in today's world, we are trying to, as Sheetal and other speakers talked about virtualization. We are trying to move a lot of developmental activities towards to a kind of PC itself instead of going to a kind of actual vehicle, which costs money and at the same time it's a lot of consuming a lot of time also. So coming back to the model-based development, yes, definitely. I think this is kind of, I would say, huge advantage, especially for the tier ones like us, because we have architectured in such a way that we have the modules or aggregates, which gets converted into a kind of subsystems, and finally it gets onto the system level topics. So we have adopted this model-based development, or the MBD in short, what we call, across all these levels, right from once we receive the requirements from our customers, so that gets converted into a kind of model-based design itself, right from the requirement stage itself. Then it gets integrated into subsystem level, finally into the system level. So when it comes to the system level itself, even at subsystem level itself, we do have planned models, we call it as, or the actual situation that can be created in a kind of hardware within the office, so that we can convert or create a lot of situations like on the road itself, and do a lot of system level testing inside the office itself, which by and large satisfies to close to around 80 to 90% of our development time, as well as development the coverage what we want to do, so that 10% can be can be done on actual road or actual chassis dynamometer testings or something like this. So in a way, without MPD we cannot imagine our development environment itself.
Thank you, Girish. I'll come to you again, Anand, and understand time to market is becoming very important when it comes to new technology or new product range that we roll out in the Indian market. Piaggio has done something in this space in three-wheeler. You have brought in electric three-wheeler in a very short span of time. Uh, Talking about the holistic, when we talk about economy of scale, because that's one of the main, barriers when we talk about reducing the cost or proliferation of electric vehicles in India, especially three-wheeler, two-wheeler buses are the biggest, mode of transportation in India, and you sit in a very comfortable space in three-wheeler. So I just want to understand going forward, do you see more of a collaboration in terms of developing platforms or modular platform which is being shared by different companies to come up, like you talked about, swapping? Why is it only we are talking about battery swapping? Is it possible that we can see more platforms being shared by different manufacturers? Do you see some kind of consortium, larger collaboration coming up to reduce the cost of R&D and probably reduce the time and other barriers that we see?
Okay, this is very nice question. Overall, in the EV era, we as a country, we are relatively in a nascent phase, right? And we are trying to explore which technology adaptation for a specific vehicle type would be best fitted or best suited for. So that we are in that mode. It's an exploration mode. I would say a year or two, we should give ourselves as a country, right, in which in direction that technology we should adapt for, and then we create a long-term plan. That's where this consortium and adaptation and commonization of parts or systems, I would say, will happen. Today in the IC engine products, we see, right, a lot of systems are relatively common between all the OEMs. Whether it will happen for EV, absolutely yes. That is the option that we all have to explore. There is no different thoughts on that. But right away might not be possible. In next couple of years, I could clearly see that is the avenue. First place, within our organization, if we can create and adapt and modular platforms, that would be one set of cost reduction. And then going forward with the collaborative approach with any other or within CM group for the same industry, that can we think about at least a common solution on certain systems. Absolutely, it is possible, and that's how only as a country we will be able to provide a cost-effective solution to our customers. But having said that, while we are doing this, right, we have to create an USP for individual products. Otherwise, there is no right. How can we protect that also? How can we offer, even if my certain systems are common, platforms are common, still we create a USP for our individual product? That also every OEM will be thinking about it, will be definitely taking care of it while adapting this commonality.
Thank you, and thank you, Tapan, for joining back. I just want to understand the Indian component ecosystem when it comes to electric vehicles. We still have, of course, most of the parts when it comes to body structure and all going to be similar to what ICE engine vehicles had. But the key core components which are going to change with the electric vehicles coming up, how do you see their capability? Do you think they have the capability, because they have been mostly uh, uh, developing or producing things based on blueprints provided by OEMs or their foreign partners? In this space, how do you see the localization kicking up in component space for EV? How difficult it
Um,
is?
I think
And
it's
what's
quite
the
challenging.
component makers, new Indian component makers, to exploit the opportunity that lies ahead?
Okay, thank you for this question, Nabil San. I think it's a very, very important question to be addressed. I see challenges and opportunities both in this space going forward. So let's look at, first of all, understand the key components which are changing from a conventional IC to a electric vehicle or electrified hybrid, plug-in hybrid electric vehicles. Key components are changing is that the powertrain is changing to electric motor, which is going to drive the vehicle. Then we have the battery, which is the power source. And then we have the power control unit, lot of electronics. At the same time, there are other various vehicle systems which are going to change. For example, the air conditioning system is going to change from a conventional mechanical air conditioning system to a electric compressor or electric air conditioning system. We'll have to have additional components like regenerative braking in the vehicle. We need to look at the high voltage current carrying cables and capabilities, and therefore the high voltage wiring harnesses. These are the 5-6 broad areas which are going to change when you look at electrification and electric vehicles. So keeping that in mind, let's look one by one in terms of what is the scope or what is the challenge and what is the opportunity that we have. First of all, you talked about raw materials sometime back, about raw material availability for battery manufacturing. It's very heartening to know that Government of India has come out recently last week for a PLI based gigawatt manufacturing scheme. So I think we need to attract investment there, give the required kind of incentives for people to come and invest in the battery technology for future. The second is that electric motors. I think the electric motors that are used in vehicles today, the power rating is very, very low, not going beyond 1, 2, 3, 4, 5 kilowatts maximum. And we need, if we want to get into drive motors, it requires a lot of precision manufacturing. A lot of new materials will come in, and therefore we need to look at that as a second step where opportunities lie. Third is power electronics. Unfortunately, India doesn't have any manufacturing setup today as far as electronic component manufacturing is concerned. So that's also again a thrust area for Government of India, which has come out with the PLI scheme, like putting up fabs, semiconductors, and all that stuff. But it's going to take a long time and gestation period for that to happen. However, if we start with assembly of these components in India, I think that also requires a lot of investment. So, and to attract investment, it's a business case which has to serve its own purpose, and therefore it should make business sense for companies to invest. And therefore, again and again, I would like to re-emphasize on the issue that we must, as a country, we must, as an industry or the ecosystem, need to look at how do we aggregate demand for these components across all electrified vehicles. When I'm saying all, it's not only from segment perspective, it's also from the kind of or level of electrification perspective. So we need to look at both. So, for example, two-wheelers, three-wheelers, four-wheelers, CVs, and all kind of electrified vehicles, how do we aggregate the demand for motors? The capacities requirement may not be same, but the manufacturing setup for these could be same, and the suppliers can supply or manufacture a different kind of different rating of motors for catering to different segments. So aggregation of demand is going to be one of the key factors or key drivers, which is going to provide the scale and therefore help in localization. I think that's a very, very important point which you need to keep in mind.
Thank you, Tapan. That's a really good aspect that you have brought into the discussion. Of course, the government's initiatives are important, but at the same time, if we talk about R&D, there was a weighted deduction about 200%. That has gone to, that a rollback to that would be a great booster to the R&D if we talk about localization. Then I think design in India is equally important if we talk about manufacture in India. The way has to go through design in India to arrive at manufacture in India. Our next question to you, Sheetal. There's a strong buzz about visualization of EV powertrain development. How can it help in front-loading design and verification? Can you give us sense?
Yes, Nabil, and I think this is that is one of the critical aspect for when we go for design in India, as you said, and for design in India, our companies, OEM suppliers would need to come up kind of the designs which are safe, reliable, and also kind of integrated to the complete vehicle. And that's where taking forward what Girish mentioned earlier, and I think I assume your question is about virtualization. So what Girish mentioned earlier, I think model-based design is the key, is the most critical aspect. And I would say it's there for quite some time. MBS is also there, but we'll have to adapt it for the EV going it further. And a specific example, if I can take, let's say if a motor design, if software verification validation or the verification and testing needs to be done. Today, your motor needs to be there in a test rig, and you need to kind of do a wait for prototype and quite wrong for accurate software in loop or hardware in loop verification validation. But what instead companies are turning towards the physics-based teams to get a accurate transfer function or reduced order model or FMU. Okay, and then this can be done in a kind of a week's time by crunching HPC, but that will makes you extremely confident for when you go for detailed testing and validation, or as well as software tuning and then so on. So you are in a way kind of front loading your software design, software verification validations, even the final design verification validations before creating a prototype. And that's tremendously increases the speed of development as well as making a most optimal component and the system.
Thank you, Shital. I'll take next question is for Anand and Tapan also, if you can contribute to this. First, Anand, from you, to support several variant and modular design needs, be part of development process. What innovation in the product development process needed to enable the platform approach? What architectural challenges that automotive OEM must have to overcome for EV?
So overall, from the platform perspective, if you're really talking about, it is already in place for today's IC world also, right? How the architecture can be evolved and can be adopted so that at least 60 to 70% components can get carry over across the products. And very similar, while doing that, I appreciate all my panel members from the which they're coming from the virtual world, right? So a lot of virtual validation has been done today in today's IT products, and similar concepts have been implemented for developing the EV, which actually helps us from time to market perspective. Having said that, now coming to the specific EV components, the approach that we have been doing, adapting in our IC engine also, if we develop a certain level of a certain IC engine, we always plan for the scalability for that. So similarly, in the motor family also, when we are looking at it, we create a family which can cater the overall product range that we can cover, and a different usage also from the duty cycle perspective, so that we can adapt the components for our different variants as quickly as possible. Virtual validation for the system optimization, we have been extensively using those tools. Without that, it was not possible to have these assessments done pretty fast and not rely only on the physical validation, which we have adapted within our new product development for the EV range also. Good.
Thank you. Tapan, quick take on this.
Yeah, thank you. I think if I may start to it, I think from a conventional vehicle to electric vehicle, the architecture will change in terms of various subsystems. So starting with the vehicle platform itself, I think that's going to change because you need to have a platform which is suitable for packaging the batteries. So that's one of the area which will change. Then you'll also have a look at electrical platform architecture. You'll have platforms in terms of vehicle suspension systems. You'll have change in the the automotive air conditioning system, and all these things are actually made modular even today, and which are applied across vehicle models, uh, typically keeping the external differentiation, but the internals may be very common even today as far as platform is concerned. So going forward, we would be no different. I think we would have a similar kind of approach in terms of making things modular, making sure that people are able to use common things and therefore reduce the development efforts, reduce the development cost, and therefore Again, that's also another way how to aggregate demand and bring in scale. That okay, you across platforms you can make the components common and bring in scale for localization.
Thank you. Tapan, I'll come to you, Girish, and understand what differences you see between global OEMs, suppliers, and the Indian OEMs and suppliers in the approach of EV development. Because we see India is one of the fastest growing automobile market, but when it comes to EV, it's very minuscule, very small market. And what are the best practices that can be borrowed from global OEMs and suppliers by Indian manufacturers when we talk about localization?
Yeah, I think good question. I think partly I think Dr. Tapan brought this topic of aggregation. See, aggregation is an important aspect for India because of the volumes where we are going through. Personally, I could see our platforms, Vitesco Technologies, as part of Continental Group. We were, hardcore IC engine suppliers till 2019, and we made a decision to come out of IC engines, injection hydraulic systems, and we started concentrated only on EVs now and the HEVs. And when we started doing that, one of the important aspect is that we started developing our common products so that it can fit. Because when we develop in Europe, I think we can go for OEM based products, whether it's an axle drive or an inverter or a DC-DC converter or a HV box, which is the important component of EV. Unfortunately, what happens, all these things will work for an high volume market like Europe, US, or China. And as Dr. Tapan said, see, for India, we are stuck. Neither we are in that range of high volume, nor from the capacity perspective also. See, we need how do you call the drive motors to be in the range of 50 to 80 kilowatt. This is what we are looking at, which is not the case in the other parts of the world. So for this, I think we are struggling really. How do we support? Even though India, as such, we have not gone to that step of complete changeover, because we are still going through this BS6 IC engine phase itself. But we are really struggling, especially our team in India. How do we scale down some of the products, global products, so that it meets the Indian market conditions? My suggestion is that even when we talk to different OEMs in India, globally also, there are different requests. Somebody asks one box where it contains all the components together. Somebody asks different components one by one. I think this, at least we can, if we can come to a kind of understanding within India, so that this is how India should go into one box or two box or three box, whatever it may be. The standardization, if we can come to a kind of single standardization, this aggregates the volume. So this helps, as all of us are from R&D, we know, developing for a low volume will not be kind of economics of scale, will not support us. We need to aggregate this. We need to come to a kind of understanding to standardize such kind of components, so that we can get the leverage of higher volume. And it becomes very difficult to push from the R&D side as well as from the investment side also, so that we can push it fast. I think this will be my statement.
Sorry. Thank you so much. This is a very important point, is standardization of component. Taking this conversation forward, I just want brief answer from you, Dr. Tapan. What role OEM is playing in fostering the technology adoption by suppliers? You are the big brother. How are you hand-holding?
No, I think like Mr. Ramaswamy just said, industry is actually just passing over the phase of BS6, and then next phase of CAFE and RDE are coming up. So a lot of activities are going on to meet the kind of requested deadlines which are being told to defer by a few years to look at overcome the economic impact due to COVID. Nevertheless, I think once that is done, I think industry is also parallelly working on in terms of electric vehicle and hybrid electric vehicle proliferation. And I think this will be one of the key aspects. However, what Mr. Ramaswamy rightly pointed out, across OEMs or across segment standardization, to me, it looks like a challenge, but at least we should have some kind of architectural understanding, which I believe is not going to be very, very different from what one is going to be doing than the other. So probably this is a challenge for the component industry for sure. But as far as we are concerned, I think when we are working on future products, we look at modularization and standardization as a key R&D component, just to take care of the volumes, aggregation, and also the localization and scale aspects. So certainly that we'll keep in mind.
Thank you, Dr. Tapal. If we talk about electric vehicles, the biggest force that we have right now is of these startups. So Ashish, I just want to understand, how is EV startup working towards maximizing its design objective? How different these objectives are for two-wheeler segments?
Yeah, so Nabil, for two-wheelers, it is not going to be very different, but yeah, a bit more challenging because you don't have, as I mentioned earlier, we don't have, much of the space available, and yes, there are range and anxieties, and then we are looking for like higher power, densities out of the entire vehicle platform. So challenges remain mostly same. Sometimes gets aggravated, and you don't have like much of leeway to play around it and provide a solution for that. So it's a bit of more challenging in terms of engineering there. How we are trying to overcome all these challenges as startup, we are investing heavily, and as all of the elite members mentioned here, simulation plays very important role here in order to do cost, take care of the cost constraints, in order to take care of the optimizations, because products today are very complex with more and more ingress of softwares, electronics coming into picture, and these become very core components for an electric vehicle. So one aspect is that yes, the engineering and technology itself is getting understood by the industry leaders. The skill sets are getting generated. At the same time, we also have to implement it and produce great vehicles at the road. All those things are happening at a very fast pace today, and these are quite satisfactory. Simulations play a very important role. Software in loop, hardware in loop, modern in loop, multidisciplinary optimizations, tools for vehicle dynamics, tools for durability, for NVH. NVH is also a bit different for electric vehicles, and is being understood even today by most of the NVH experts in the industry. So use testing and validation, the real life physical validation, to understand the physics and phenomena more and more. Couple it with simulation to learn to have your lessons learned, and then try to convert the most of the testing and validation in through take them through virtual mode. That's how we are looking at the design challenges today, in order to keep track on the cost as well as on the quality and performance.
Thank you so much. We are running out of time, so I'll take last question, and I would request everybody's brief answer to it. You all are veteran of the industry. You have been working on this transition quite closely. I just want to understand the key recommendations from all of you when it comes to EV design and development and manufacturing in India by India. Means complete Atmanirbhar EV ecosystem. What would be your recommendation? I'll start with you, Shital.
Yeah, thanks for it was a pretty good discussion. And yeah, my closing comments are going to be on line of developing a technology platform which is going to be interoperable, multi-physics, multidisciplinary, which would help designers who develop their own designs for kind of India to have a more optimal, safe, workable, good performance as it's expected. That's possible. So developing that platform is going to be, I think, key for R&D teams across this OEMs and suppliers.
Tapan, your take.
I think for electrification going forward, it's a journey that we're going to take. I'll be very precise. The industry need to recover its investments and make a smooth transition. So all kind of electrification need to be encouraged, and we should make the electrification journey for the consumer convenient and attractive, so that the transition is smooth and we are able to take the journey in the right spirit. We should not say we should be doing X technology, Y technology. We need to look at how do we make sure that all components of electrification, what we are planning to do, are made in India, designed in India, and our engineers take a good, are able to contribute in a big way in that. That's my take for future.
Anand,
So
your
all policymakers, industry, everybody should come together to see that electrification, hybrid vehicles, electric vehicles, plug-in hybrid vehicles, all we should put our efforts to make sure that it's attractive and leave it to the consumer to decide which one he wants to buy, but make an ecosystem which is sustainable.
Ashish.
I completely agree with Tapan there, right? So what we need to do is OEM suppliers as well as government as a ecosystem creator. We need to collaborate in next 5 to 10 years quite elaborately to make this successful. The way we have done BS6 transition also as a country on a very fast track, right? With collaborating with all of us together, I believe the similar footprints can be followed for the EV product range also. Yeah.
Yeah, Ashish, your take.
Yeah, so nothing different than what every panel member just said. Definitely, if we have to make EV success, in India, then government policies, government support, uh, also making products which are customer centric, where we are talking about the customer experience, through not just electric vehicles but also in terms of smartness connected, that will propel the demand for the electric vehicles. So industry, not just OEMs, but also the component development, manufacturing, uh, uh, and the Indian government, the policies and all those things have to go hand in hand to make India self-reliant towards the manufacturing and adoption of electric vehicles, in my view.
Grish, your final comment.
Yeah, I think ecosystem is one thing which I would like to again stress, like others. On the other hand, from the organization perspective, as I said earlier, also we are really ready. As I said, we have already stepped out of IC engine development now. We are purely into EVs. We already have huge investments in our Pune plant, to bring up EV components, and we have a large R&D in Bangalore, which is working purely on EVs. I think from my perspective, we are already there. Just we are waiting for the market, to mature so that we can really become local for local.
Thank you so much, everyone, for joining in ETAuto panel discussion today. Those were very thoughtful discussion that we had on the design and development of EV when it comes to Atmanirbhar Bharat. I'll come back again with another panel discussion. In the meantime, I would like to hand it over to Annie. Thank you so much, everyone, for joining. I could not take up the question, but please post your questions. I'll send them to the experts and get them answered. Thank you so much once again.
Thank you so much.
Thank
Thank
you.
you.
Thank you, panelists, for deep delving into the topic and for imparting valuable takeaways.